Now, in the last video, we talked a lot about defining the symbol pi. So, for anyone who hasn't seen this before, check out the last video. We talked about kind of the origins of it and how we started to approximate a value for it. And pretty much the most important conclusion we came to is that pi is essentially a constant. It is an irrational number, but it is an irrational constant that links the circumference and diameter together. So this is expressed, I should say, essentially as the ratio of the circumference to the diameter. So we express this as a kind of like a fraction here. And we also defined a value for pi to be approximately 3.14 and a bunch of other decimal places because this is an irrational number. Now, we are going to take these two bits of information we've learned and start working through finding the circumference of a circle using this relationship here to start to work through some actual problems here. Now, I'm going to move this over here. And we will start to work through the example on the left here. Now, I'm given this circle and the diameter, so the distance from one point on the border of the circle to another, passing through the center of the circle, this distance is 66 meters. Now, because we have expressed pi as the ratio of circumference to diameter, this is just a type of equation. And what we've learned from equations, we can just rearrange this as we need to solve for different things. Now, if our circumference divided by our diameter gives us pi, we can think of our circumference as being equal to pi times our diameter. And we know that pi is about 3.14. And on your calculators, if you've been given a scientific calculator in school, you will be able to generate the constant pi. So this will give you a far more accurate result. But let's find this circumference here to correct to one decimal place. So if I plug this into my calculator, I'll get that my circumference is about 3.14. Well, let me actually just leave this as pi because you can use this at home with your own calculators. That'll be pi times 66 meters. Now, when I plug this in, I'll get about 207.345, etc. And it makes sense that we're going to have a lot of decimal places here because we're multiplying our diameter by an irrational number, a number that has a bunch of decimal places. So often when we work through things like this, we specify some level of accuracy. We round typically in these examples. So rounding to one decimal place here, I'll just get that this is equal to 207.3 meters. Once we understand what pi is and this relationship up here, we're really just plugging values into our equation. This will work for a variety of different things. Now, let's take another example, and we are going to slightly change this up a little bit. So I have my circle once again. Oops. Just doesn't want to move now. Here we go. Now let's add another kind of little dimension to this. Change this a tad bit. So I have this distance here, and I want to once again find the circumference of this circle. Now, how does this question differ from the other one? Well, here we're looking at the distance given here is the distance between the center to the border here. And there's a special name for this distance, and this is called the radius. So we've talked about this before, but the radius is just the distance from the center to any point on the border. It doesn't matter which point we choose. The distance in this case will always be 13 centimeters. Now, an important thing to note about our radius is that it's just half our diameter, because the radius just comes from the middle to the center point, and going from the center point and stretching this all the way through to another border to make a straight line, well, we're just going to get two lots of this line. So just to make a note of that, my diameter can be expressed as two lots of r. And when we write this in this form, we just imply that these two are getting multiplied together. So our diameter equals 2 times r. So if our circumference equals pi times the diameter, well, I can also write this as the circumference equals 2 times pi times r. So pi times 2 lots of r. So these are the exact same thing. The only difference is we're working with a radius here instead of a diameter. Now, taking these values here, I'm just plugging this in again into my equation. Sorry about that. I have pi multiplied by 13 centimeters multiplied by 2. I could have also said, well, the diameter is 2 lots of r, so the diameter is 26 centimeters, and just done pi times 26. It's just different ways to get to the exact same thing. So plugging this in to my equation and putting it into a calculator, I will get correct to one decimal place about 81.7 centimeters here. Now let's do one example, and I will switch this up one more time. And this should give you a good understanding of how we can work with all of the things that we've learned today. So drawing up another circle here. I should probably put question 3, hey. There we go. So I'll make this nice and big. And I'm going to tell you something different here. I'm going to say that we don't know what our radius is, but we're given that this particular circle has a circumference of, let's say, 32 meters. So we don't know what the radius is, but we know that the circumference is this entire length around the border of our circle. So kind of just stretching all the way around here. Now, this is a little bit different to what we dealt with before, but let's just revisit our equation that I gave you guys earlier. Well, these kind of important bits of information here. Let me actually drag that down. Oh, never mind. I'm going to write it out again because my software is playing up a little bit. So our pi is the ratio of our circumference to our diameter, and our pi is roughly 3.14. And we're going to use this once again. So what are we actually trying to find here? Well, based on this equation, we're trying to find the radius here. Now, because pi equals the circumference over the diameter, we can also say that, well, pi equals the circumference over, and I have a radius here, I have r. I don't have that in this equation, but I can rewrite this equation to account for r, to help us kind of solve for this value r. And the radius is just half of the diameter. So we can write the diameter as 2r here. Oh, 2 lots of r. Now, all we have to do is just make r the subject of our equation, because that's what we're essentially solving for. We're given this value here, and we know what pi is. Now, let me actually just rewrite this first. Well, pi equals our circumference here of 32 meters on top of 2 lots of r, which we don't know. Now, because we don't know this, we want to change our equation up. We want to solve for r here. So we can multiply both sides here by 2 lots of r, and that will clear this fraction on the right-hand side. And I can say that 2 times r times pi equals 32. Now, I'm saying, well, 2 pi multiplied by r gives me 32. So I can express r as 32 divided by 2 pi. And I can just put this into my calculator. I'm going to get an ugly number again because my pi is irrational, but that's okay because I'm just going to round that off to 1 decimal place. Now that gives me about 5.1 meters here. And that checks out, right? In all of our cases, the radius was, quite a bit smaller than the circumference. And that makes sense because to get our circumference, we multiplied our radius or our diameter by pi. Or in terms of when we talked about the radius, we multiplied 2 by the radius by pi. Now, we have our radius here, and we can also find the diameter. That's just 2 lots of our radius. So just as a little side note, let's just say our diameter is 2 times 5.1, and that'll give me 10.2 meters. And just to kind of verify this roughly, our circumference is just pi times the diameter. So 10.2 times 3.14, that's going to give me something pretty close to 32. So we've got a good estimate here. And it's important to note that every value we get here for our diameter, our circumference, our radius, that's going to be an approximation because of this irrational number pi. All those decimal points are going to give us a really ugly solution for pi for circumference, for diameter, for circumference, for radius in our calculator. So typically in the questions you'll get, you will usually be rounding this to some degree of accuracy, to a certain amount of decimal places, or just to the nearest meter or to the nearest centimeter. So thanks for joining me, guys. And I will be talking about the area of a circle in the next video. I'll see you there.